All right, this is our last secret of life oriented chapter. Basically moving from how the code works and is regulated to, now that we know how the code works, what can we do with it? And eventually, what should we do with it? Yeah, no, that's where we're going, is the glow-in-the-dark cat, for sure. But it takes a while to get there. We're going to learn some technology. And so I'll teach you how to make a glow-in-the-dark cat. Then I'll teach you that basically, it's very cool that you know how to do it, but that technology is almost obsolete, and we have a much easier way to do it. But we're going to start with like low tech. We're going to start with the way that humans have actually been genetically engineering other organisms for literally 6,000 years at least. Yes. What is this thousands of year old method? Anybody? Yeah, it's like, I mean, the only technology it really takes, and it's only if you're dealing with animals, is a fence. It's basically the idea of, I like that one because it's smart, and I like that one because it's fast. Let's put them in a room together and see if we get a smart, fast one. That's it. Selective breeding is exactly right. It's basically picking the ones you like, letting them breed, and not the ones you don't like. And what I just described, crudely, was a technique called hybridization. Really, what I just described was how you make a mule, right? Because the donkey's the smart one, you got the big brains. People think they're stubborn, they just remember the bad stuff that you do to them. And the horse is the fast one, big, strong, fast horse. The other thing is donkeys can see all four of their feet. Horses can't. That makes donkeys very sure-footed on like mountain paths. That's why you see them in the Grand Canyon. And so made a horse and a donkey the right way. One has to be male, the other one has to be female. You get a mule. And a mule is basically, you know, smarter and more sure-footed than a horse, but faster and stronger than a donkey. That's called hybridization, when you take two different organisms and try to get their good traits into an offspring. It's got limits, obviously, because, you know, even our definition of species includes if they're different species, they can't interbreed. You can push that a little with something like a horse and a donkey because they can. It's just that their offspring aren't fertile, right? So you have to keep breeding horses and donkeys to get mules, but it works. Kind of the opposite or the inverse of converse of hybridization is once breeders get something they really like. Dogs are a good example of this. Anybody have a purebred dog, like with papers and everything? So the way you keep purebred dogs pure, not to like make it weird or anything, is inbreeding. You want to keep those traits? Well, you breed closely related organisms. Which works great to keep the traits you like. It really does. But it comes at a cost, which is the reason that I saw the room get slightly more uncomfortable when I said inbreeding. We're kind of trained that way, aren't we? Inbreeding is gross, not a good idea, bad, against the law. Well, there's a reason for that. You know it? It's not just because it feels weird to think about. Not really about mixation.
Like what we talked about with like the sickle cell thing,
Mm.
these traits that get like attached to like a heterozygote,
Mm.
because they're so similar, there's so much more chance of those like traits happening because they're the same. They get it from the same like branch.
Yeah. Every one of you has horrible recessive traits that you're carrying, right? We all do. Like, you've got born with no head, and you've got legs fall off. I'm making these up. You've got like skin turns into, I don't know, something weird. You've all got those, and we're never going to see them because that recessive allele you've got for something horrible is never going to match up with another recessive allele when you have kids. Except if you have kids with someone who's closely related to you, suddenly the odds go way up that you both have legs fall off disease, right? That you both are carrying that, and it can come together in an offspring. So that is why we don't encourage, in fact, we actively discourage inbreeding in humans. And it's why dog breeding is kind of undergoing a little bit of a revolution now. It's why you see all these hybrids, right? Breeding breeds together. They're basically trying to get some diversity into the mix because most of those breeds are inbred beyond belief, right? And every once in a while we see huge problems. You don't see most of them because the dog breeders take care of them, like they get rid of them. One of the big problems and one of the secrets of dog breeding. It's why every once in a while I think they had to basically breed intelligence back into the border collie. Border collie's known for being smart. Well, not for a while because inbreeding, right? So the disadvantage and bring together recessive alleles. So that's your low tech version of genetic engineering. Seems simple, just buy a fence. Even easier with plants, right? Just replant the seeds from the plants that were better. Works great. Can change things like you wouldn't believe. Dogs are a great example of that. Dogs all have one common ancestor. You know what it is? Gray wolf. Look what we did with the gray wolf. I mean, seriously. I wonder if they're embarrassed. Right? Like we did that on purpose. Now, most of the weird things about these dogs, or maybe you don't think they're weird, I do, happened in the last couple hundred years, starting with Victorian England, when people, dogs became sort of a status symbol, and these breeds became something, they wanted to sort of keep the blood pure and whatever, weird stuff. But like that relationship between wolves and humans started thousands of years ago. There's some questions as to how it started. We're going to watch a movie soon about that talks about the two kind of competing hypotheses about how dogs and humans started hanging out. But eventually it came to this, and you find out that, man, that is really a powerful technique if you can make, this and this from the same DNA. Just breed the ones that look the way you want them to look or behave the way you want them to behave. Plant example, this is a good one, corn. This is teosinte, which is a plant that grows in the Andes Mountains in South America. It's gross, tastes real bitter. You wouldn't want to eat it. And somehow, over the years, by basically just replanting the seeds from the ones that tasted a little bit better, a little bit sweeter, that were a little bit more nutritious, we got, corn, which is awesome. Yeah, so real powerful. All right, moving up the ladder of technology. Turns out that if you want to do selective breeding, one of the really useful things you can do, if your test subjects can stand it, is make mutants. Right? Selective breeding requires differences that you choose to let breed or not let breed. And so it goes faster if you have more differences. And so inducing mutation with mutagens is something that can be done. Not real easy with animals. Animals don't tolerate that nearly as well as plants and bacteria. But if you've ever been to like a state fair and seen prize-winning gigantic, I don't know, pumpkins or tomatoes, you're probably looking at a polyploid tomato or pumpkin. Polyploid means they have an entire extra set of chromosomes. It'd be like, instead of 46 chromosomes, me having an extra 23 for 69. That would be a triploid human. It would not survive. A pumpkin, on the other hand, can, and it makes bigger fruit for whatever reason. And there's a chemical called colchicine that you can expose seeds to that will induce those polyploid mutations. Bacteria, you can do it all day. I mean, you can irradiate bacteria and get all kinds of weird mutants and then pick the ones you like the ones that we use to clean up oil spills. Oil that actually digest, bacteria that actually digest oil. Pretty cool. Questions? That's probably enough for a Monday. It's a pretty good start. Tomorrow, we will start with what you want. We will start with the tools you need for the glow-in-the-dark cat. For now, guided reading. This one's going to be digital. Okay, I know. I just didn't have time to print it because I just wrote it this morning. So it'll drop in the classroom. You will complete the questions in red font, please. It'll be due Wednesday by class time.